We finally know when Earth will cease to exist. It'll happen when the sun enters its red giant phase. Are we going to survive long enough to witness it all? Let's figure it out. In 5.4 billion years from now, our star, which is a yellow dwarf at the moment, will run out of hydrogen in its core. The sun's core will heat up and become denser, causing the star to grow in size and turn into a red giant. The expanding sun will get so huge that it'll encompass the orbits of Mercury, Venus, and probably Earth. Even if our planet survived being consumed on the spot, it'd still end up so close to the heat of the newly born red giant that it'd scorch our planet. No life would be able to survive there. At the same time, there might be another outcome. As the sun expands, Earth's orbit might change too. You see, when our star reaches the final stages of its stellar transformation, it will lose unimaginable amounts of mass through extremely powerful stellar winds. It'll keep growing and losing mass, making the planets of the solar system spiral outward. So can it help Earth escape its dooming grasp? According to astronomers' calculations, our planet will not survive the expansion of the sun in any case. By the time our star reaches its largest radius, which is going to be 256 times its current size, it'll be down to a mere 67% of the mass it has now, and the expansion process will be very rapid. The sun will sweep through the inner solar system in only 5 million years. At one point, it'll enter a short helium-burning phase, which will last around 130 million years. During this time, it will expand beyond the orbit of Mercury. After that, the sun will swallow Venus. By the time our star approaches Earth, it will be already losing as much as 8% of Earth's mass every year. Speaking of our planet's chances, we've got some kind of a good news, bad news situation on our hands. The bad news is that our planet won't be able to live through the expansion of the star. Even if Earth's orbit became 50% more distant from the sun than it is today, it'd still have no chance. The sun would engulf our planet even before reaching the peak of its red giant phase. After that, the star would still have 500,000 years and 0.25 AU to grow. Once Earth is inside the sun's atmosphere, it will start colliding with particles of gas. Its orbit will begin to decay, and the planet will spiral inward. If Earth was just a bit farther from the sun right now, at 1.15 AU, it would survive the expansion phase of our star. But what can be considered good news in such a tragic situation? Well, long before the sun enters this red giant phase, the habitable zone around it will be gone. The heat from the sun will evaporate Earth's oceans, and solar radiation will blast away the hydrogen from the water. Devoid of its main source of life, Earth will eventually become molten. It doesn't sound like good news, that's true. But the upside of this situation is that humanity will be bound to leave our planet long before it gets swallowed by the sun. We just won't have a choice. Of course, we can't be sure that some other catastrophic event won't claim us before we have time to colonize some other world. An additional benefit of the changing boundaries of the sun's habitable zone might be the restructuring of the entire solar system. Even though Earth won't be in our star's habitable zone anymore, most of the outer solar system will be. This zone will stretch well into the Kuiper Belt, which means that the formerly icy worlds will melt and liquid water will appear beyond the orbit of Pluto. So maybe that's where our new home will lie.
You wake up with a start, open your eyes and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual. Blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the red planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars. You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear. you're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. It would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings.
In 1859, British astronomer Richard Carrington observed a peculiar solar phenomenon. Two bright patches of light on the sun, marking the discovery of the Carrington event, the most massive solar storm ever recorded. This was a time before the invention of the light bulb, a period of burgeoning scientific discovery. This event led to unprecedented auroras, visible from the equator to the poles, so vibrant that in some places like Missouri, nighttime felt like daytime. The sun's intense activity caused more than just stunning lights. The surge in electricity disrupted telegraph lines, with telegraph machines in Paris spewing sparks and sending messages without batteries. In contrast, those in Pittsburgh could communicate with New York. Fast forward to modern times, there are concerns about another potentially devastating solar storm in 2025. With our heavy reliance on technology and electricity, the impact could be catastrophic. A Carrington-level event could disrupt power for up to 40 million people in the US alone for years and cause trillions in damages. What are solar flares? They're massive explosions in our solar system caused by the sun's magnetic energy. When these electromagnetic waves hit Earth, they cause phenomena like the auroras, but also disrupt satellite operations and power grids. Case in point, in 1989, Quebec experienced a 12-hour blackout due to a solar flare. And in 2022, a solar storm sent 40 Starlink mini-satellites crashing out of orbit. The sun doesn't only emit flares, but also coronal mass ejections, CMEs, enormous bubbles filled with plasma. Both emit radiation and particles that can overload our power systems and have frequencies much higher than our usual electrical devices. If a storm of the Carrington magnitude were to strike again, it might take up to a decade for us to recover. These solar events can damage satellites, disrupting communications, including the internet, TV, and GPS. The radiation could have lasting effects on our DNA, particularly hazardous for astronauts in space. By 2025, it's hoped we'll be better prepared. Maybe a brief internet break wouldn't be too bad after all. Moreover, it is important to understand the potential risks posed by solar storms and to work proactively to mitigate their impact. The Carrington event in 1859 showed that even the most advanced technologies of the time, like the telegraph system, were vulnerable to solar storms. Today, with our reliance on complex electronic systems and the interconnectedness of our global economy, the stakes are even higher. One way to protect against potential solar storm impacts is to develop technologies that are resilient to the effects of solar radiation. Researchers are working on new materials and technologies that can shield electronic components from the harmful effects of solar radiation. Satellites and spacecraft can be designed with radiation-hardened components to withstand solar storms. Power grids can be fortified to minimize the risk of large-scale outages. Another important step is to improve our ability to forecast solar storms. Current models for predicting solar activity are based on observations of sunspots and solar flares, but these methods only provide short-term forecasts. New methods that rely on a combination of ground-based and space-based observations as well as computer simulations could provide more accurate and timely predictions of solar storms. This would give us more time to prepare and take action to mitigate their impact. In addition to improving our forecasting capabilities, it is essential to invest in infrastructure that can help us respond to and recover from a major solar storm. This includes backup power systems, alternative communication networks, and stockpiles of essential supplies. With proper planning and preparation, we can minimize the impact of a major solar storm and ensure the continuity of our economy and society. In conclusion, while solar storms can pose significant risks to our modern society, with proper planning, research, and investment in infrastructure, we can mitigate their impact and continue to enjoy the many benefits that the sun provides. The key is to be proactive, to understand the risks, and to be prepared to respond to whatever challenges the sun may throw our way. The Fermi paradox essentially queries, why haven't we heard from anyone out there? And why weren't we included in the cosmic conversation? One of the potential explanations for our solitude in the vast expanse of space is the concept of the Great Filter. This idea, introduced in the 1990s by Robin Hanson, postulates a significant barrier or challenge that may prevent life from proliferating across the cosmos. This Great Filter is a metaphorical sieve that civilizations might need to traverse to achieve the kind of advanced state we often fantasize about in sci-fi tales. You've probably seen something like this in the game about Captain Shepard. Regrettably, evidence of such advanced civilizations or even basic extraterrestrial life remains elusive. It could be that evolving into higher life forms or mastering interstellar travel is a monumental task. Such an impediment might halt civilizations from progressing, either due to natural cataclysms like asteroid hits and ecological crises, or by their own actions leading to self-destruction. Analyzing this theory, we face two intriguing possibilities. The first suggests we've already navigated past this daunting filter, meaning we've weathered the toughest trials of existence. Yay for us! But this would imply that intelligent life is a rare gem in the vastness of space, leaving us potentially unique and isolated. So our dreams of interstellar friendships and explorations might be just fantasies. On the gloomier side, the second possibility posits that the most challenging tests lie ahead, indicating that while other civilizations might exist, they too face challenges they've yet to overcome. They, like us, might be striving to survive, evolve, and hoping to signal to the cosmos that they're here. Within the discussions of the Great Filter, there's mention of the rise of artificial intelligence, AI. With AI's rapid advancement, it's conceivable that it might turn out to be a double-edged sword for humanity. AI, as highlighted by the Great Filter theory, presents both an opportunity and a challenge. As this technology surges ahead, becoming increasingly integrated into our lives, there's a growing concern about its unforeseen consequences. If not handled responsibly, AI could end up being one of the hurdles civilizations, including ours, struggle to surpass. The potential for AI to reshape our society and even pose existential risks underscores the importance of cautious advancement. Yet, it's crucial to remember that the universe is vast, and the narrative isn't solely one of doom and gloom. There's a silver lining. It's possible that other civilizations, having navigated past their great filters, are thriving in distant corners of the cosmos. Their successes could eventually pave the way for us to communicate, collaborate, or even coexist. Furthermore, life in its most rudimentary form might be closer than we think. Entities not yet sophisticated enough to establish contact might inhabit realms within our reach. Our quest might not always lead us to advanced civilizations. Even the discovery of microbial life would be groundbreaking. Amidst all the speculation and theories, one thing is certain. Our thirst for knowledge remains unquenched. The scientific community remains undeterred in its mission. With every passing day, we probe further into space, and particularly our solar system, hoping to unearth evidence of life. Discoveries, such as water on Mars or conditions suitable for life on some of Jupiter's or Saturn's moons, emphasize that we might not have to venture too far to find hints of life. The universe, with all its vastness and mysteries, continually beckons. We remain eager to uncover its secrets. As we continue our journey through the vast expanse of the universe and its mysteries, your support and curiosity drive us. If you want to stay updated on more such revelations and insights, make sure to subscribe. Together, let's keep exploring the unknown. Don't miss out. Hit that subscribe button now.
A black hole is an eerie place where those laws of physics we studied at school stop working. If a massive star runs out of its fuel, it sometimes becomes super dense and buckles under its own weight, collapsing inward and bringing space-time along. As a result, the gravitational field of this new object gets so strong that nothing can escape it, not even light. That's how a black hole is born. The black holes closest to our planet are called Gaia BH1 and Gaia BH2. They were discovered thanks to the data collected by the European Space Agency's Gaia spacecraft, hence their names. Both are about 9 to 10 times more massive than our Sun and are located a mere 1,560 and 3,800 light-years away, respectively. In cosmic terms, they're situated in Earth's backyard. And there's something seriously wrong about these black holes. So, should you pack your emergency bag? Let's find out. The remarkably close black holes are likely to represent a previously unknown category of these mysterious objects. What sets them apart from others is that they're orbited by stars at much greater distances than scientists have observed previously in other black hole companion star pairings. Normal black hole companion star systems are known as X-ray binaries. They are usually bright in radio and high-energy X-ray emissions. They swallow matter and emit powerful bursts of energy, which makes them pretty easy to spot. Now, why did it take astronomers so long to spot these massive black holes residing right inside our home Milky Way galaxy? All because they're almost invisible. In the past, astronomers spotted black holes by looking for the remnants of their meals. The thing is that when a star or even a cloud of interstellar gas is pulled into a black hole, it leaves behind a trail of electromagnetic radiation. And scientists use it to detect the presence of a black hole. But unlike other holes discovered before, Gaia BH1 and BH2 are pitch black. They don't seem to be snacking on anything at the moment. This makes them inactive, or dormant. So astronomers had to use another method. They tracked the movement of two companion stars orbiting these cosmic monsters. The stars, similar to our Sun, wobbled a bit while traveling through space. To researchers, it was a sign that something with a lot of gravity, like another star, was tugging on them. Interestingly, when they examined the area with the help of telescopes, they didn't find anything emitting radiation. So the whole situation only made sense if there was a black hole involved in the process. Luckily, Gaia is perfect for spotting invisible black holes. Thanks to its state-of-the-art equipment, it can accurately measure the motion and position of billions of stars. No other instrument is capable of such precision. Gaia's observations were backed up by the data received later by other observatories. For instance, NASA's Chandra X-ray Observatory, as well as the South African Meerkat Radio Telescope, revealed no visible light coming from Gaia BH2. So even though they detected nothing, it was still valuable information. It told astronomers a lot about the environment around the black hole. A lot of particles are coming towards it from the companion star in the form of stellar wind. But the researchers didn't spot any radio light. It means that the black hole doesn't have much of an appetite, and not many particles cross its event horizon, or the point of no return. Unfortunately, it's still unclear why that is. Anyway, should we be worried about those mysterious black holes lurking in the darkness of space so close to our planet? I've got some good news. There's absolutely no reason to worry. First of all, these black holes are sleeping at the moment. And it doesn't look like they're going to wake up anytime soon. Secondly, they're still too far away to affect our life. And it's not like black holes know how to travel.
One of the greatest riddles the universe baffles us with is why there is so much more matter than antimatter. The thing is, according to the laws of physics, you can create and destroy matter and antimatter only in equal amounts. But when we look at stars, galaxies, and other large-scale space objects, we see that all of them are made of matter. Only small traces of antimatter can be detected in the cosmos. So the question is, could an equal volume of antimatter exist somewhere? Maybe at one point it just got separated from regular matter? And if it's so, could black holes be that place that contains all the lost antimatter in the universe? If the total mass of supermassive black holes was approximately the same as the amount of that missing antimatter, it could really be the answer. So let's try to figure it out together. At first sight, it may seem that the universe isn't homogeneous and galaxies clump and group together. But if you look at it on a very large scale, you'll understand that the universe has the same properties everywhere. If there was a galaxy made out of antimatter instead of regular matter, we would spot a great number of matter-antimatter annihilation signatures. But since we don't see them anywhere, not in clusters of galaxies, not in individual ones, and not even in colliding clusters of galaxies, we can conclude that almost 100% of the universe is matter. But this is kind of confusing because, according to the current laws of physics, there are no mechanisms that can create more matter than antimatter. Let's take quarks, elementary particles that are building blocks of all visible matter in the universe. Every time we create a quark, an antiquark also forms. And when a quark is destroyed, an antiquark stops existing too. The only way to create more or less matter is to make equally more or less antimatter. The only seemingly logical explanation can be that in the universe's past, more matter than antimatter was created. In the standard Big Bang picture, when the universe was in its early stages, particle-antiparticle pairs of all known and yet to be discovered particles appeared in tremendous abundance. All because at high temperatures and densities, new particles-antiparticles can be produced spontaneously from pure energy. Then these pairs annihilate, producing pure energy photons again. When the universe cools down, it runs out of energy to create new pairs, and the annihilation process becomes prevailing. But what if, at one point in the early universe, something made antimatter collapse into black holes while leaving regular matter behind? After all, we have discovered quite a few ancient supermassive black holes. But then, there's a theory of direct collapse. According to it, some black holes don't need stars to run out of their space fuel and go supernova. Instead, they simply collapse. This process could create seeds, large and fast enough to grow into the young quasars we see today. According to some theories, quasars contain massive black holes. So we can most likely rule out supermassive black holes. But there are also hypothetical primordial black holes. They're often viewed as candidates for dark matter. These holes, if they exist, can't be too light. Otherwise, they'd have decayed. Neither can they be too heavy. This way, we'd have already spotted them. So, most of the possible mass ranges allowing for primordial black holes to be the missing antimatter are already ruled out or very tightly constrained. But in any case, astronomers have managed to estimate the total mass of all black holes in the universe, and it turns out to be approximately 0.007% of the total energy in the universe. And given that there's around 700 times as much normal matter as there are black holes, we can make a disappointing conclusion. Black holes can't be where antimatter is hiding. Neither can antimatter form black holes. The universe somehow managed to make more matter than antimatter at some point in the past. That's actually why we appeared in the first place. But how exactly it happened still remains one of the biggest mysteries in physics today.
Imagine that Earth's rotation stops one day and tomorrow never comes. Life will never be the same. But if you can escape to an underground bunker, you may have a chance to carry on. Normally, our planet makes a rotation every 24 hours at a speed of 1,040 miles per hour. This is faster than the speed of sound and several times faster than the fastest cars in the world. We don't feel it while it's rotating, but we will when the Earth suddenly stops. At the last second, you run into an underground bunker. You close the hatch, go deep underground, and hear the chaos that has begun on the surface. All the people, houses, cars, ships, roads, trees, animals, topsoil, anything not connected to bedrock will fly off to the east. Hurricanes and tsunamis will appear. The endless day brings huge global earthquakes, and volcanoes will awaken and erupt, threatening to destroy everything. Meanwhile, you're drinking tea and waiting in the bunker until the catastrophe ends. 2 days later, you realize that silence has come to the surface. You go upstairs, open the hatch, and water flows inside the bunker. Great, your shelter is flooded. You swim to the surface and find yourself on the middle of the ocean. Fortunately, a big ship passes by with other survivors and they take you on board. You're looking around and realize that the water seems to be almost everywhere on the planet now. Since the global stopping, the water on Earth has united into two oceans, the North and South, and all continents have become one, connected on the equator. You and the survivors sail a very long time under the scorching sun. Then night comes, not because the day has finally ended, but because the ship has arrived at the other half of the Earth. The unbearable heat is replaced by terrible cold. You're finally approaching the equator, and you can see land, but unfortunately, everything is frozen here. On this side of the planet, all nature freezes and night never ends. It'll be very difficult to move around to get food. You need to find the land on the warm half of the planet. Weeks later, you arrive, but find nothing except a desert. The temperature is so high that agriculture can't be created here. You start to worry that there's nowhere for you to go. But there is one area. The border between the hot and cold halves have ideal conditions for living. Places where you can watch the endless sunset or dawn. You arrive here and finally get some rest and sleep. But it turns out now you have some problems with this too. Your sleep biorhythms are damaged because of the long bright day and the long dark night. This affected your psychological and physical development. It takes a while for you to fall asleep. But life is getting better. You build a house, even start farming, but not for long. The temperature drops very fast and it becomes colder and darker outside. This happens because the Earth is slowly spinning around the Sun and the borders are shifting. You build a motorhome and travel around the world, following the space between the hot and cold sides of the planet, with long stops to enjoy sunsets and rises. You hear a strange sound, the sound of storm. A big wave approaches you. Come on, what's happened this time? Well, the Earth's shape has changed. Our planet has become more of a sphere or ball. Before, the Earth's shape was flattened because of the fast rotation. It was wider at the equator and had a slightly flattened circle shape. When the Earth stopped, it became perfectly round. The world's oceans change again. Floods are inevitable. Fortunately, you have a little boat and you sail around the world once more. When you find land, you face another big problem, but this time it's not from Earth. It's space radiation. The old magnetic field worked thanks to the Earth's rotation. It protected us from the solar winds, ultraviolet radiation, and radiation from the deeps of space. Now it's gone. Without it, existence on the surface of the planet is impossible. Time to go back underground. You're hiding in a new bunker with other survivors. You dig tunnels, build underground cities, and only go to the surface in special protective suits. But there is nothing left. No plants or trees or animal life. You have to grow wheat and plants in the underground city using artificial lights. But things could be even worse if the Earth halted completely. If the Earth stops spinning around the Sun's gravity will pull our planet so quickly that people won't have time to create a huge spacecraft to evacuate. Normally, our planet spinning around the Sun is like riding a fast carousel. You can't get too close to the center because of the high speed. In fact, billions of years ago, the Earth rotated even faster, and days passed in 14 to 18 hours. But every 100 years, the day length increases by about 2 milliseconds. And what if the Earth rotates backward? Unfortunately, there won't be any time traveling to the past. Continents and oceans would remain in their place, but the weather conditions would greatly change. Using computer simulations, you find that deserts would cover North America and replace the Amazon rainforest. Western Europe will be much colder. Central Africa will be overgrown with lush forests and green fields. Dense trees, rivers, and lakes would appear in the Sahara Desert. You wish you could live in a place with a very long day, without catastrophes, where the sun is always warm, the flowers are blooming, and people are happy. Well, there were such places like this on old Earth, close to the North Pole: Finland, Sweden, Norway, Canada. These long sunny days are the result of the tilt of Earth's axis. Up at the top, the North Pole just can't hide from the light. The shortest polar day lasts almost 2 days, and the longest is about 6 months. However, a place where the sun always shines exists nowhere on Earth. Sooner or later, night will come. Before the Earth stopped rotating, you could visit the northern parts of these countries and enjoy one day lasting spring to autumn. But it wasn't all that easy. Tourists suffered from insomnia. You'd fall asleep, wake up, and spend all your time while the sun continued to shine. Just like you have become used to your life underground, the locals were used to this life too. They didn't follow a certain sleep schedule and fell asleep when they felt the need. The endless sun saturated people with vitamin D and provided a lot of energy and productivity. But a long night followed after the long day. The lack of sun can cause depression. But people of the North fought it with the help of skis, baths, and a fabulous atmosphere on the streets. Cafes, houses, parks were decorated with bells and lights, so you felt like you were in a winter fairy tale and didn't have a bad mood. Maybe, if the Earth starts to rotate again, you can visit them in the future.